The second talk is about a controversial subject where we lost so many people, they got food, they went away. Typical developer. And the problem is that I give this talk in different countries, and I don't want to hurt your feelings. If you feel hurt by what I'm going to say, you just leave, right? Don't be offended. I know in some Americans, they can be offended when I talk, so just don't be offended. Yeah, she's very serious. Yeah, okay. That was supposed to be a joke, but that's fine. More seriously, there is, I believe, a big issue at the moment because if you are doing microservices, you are considered a good developer, and if you're doing monolith, you are a bad developer. Who here is doing microservices? Oh, come on. Oh, fuck. No, that's not true. I don't believe it. Everybody should be saying, yeah, I'm doing microservices. Who is doing microservices? Chestnut. Ah, okay. So I leave it up to you to answer by yourself. So this talk tries to check why, what, any alternative, what the problem. So I believe we all agree on what are microservices. If you don't agree, then you go to Martin Fowler, you tell him that he's talking bad stuff, but this is his definition. In general, half the room does microservices, really. I do the talk every time, and a lot of people, I do microservices. In general, I disbelieve this because we go through each step. Componentization via services, yes, that's the basics of microservices. Organized around business capabilities, yes, that's also basics of microservices. And we go down until here, products, not projects. So products, they don't have an end date, or more precisely, they don't have a planned end date. When you start a product, you don't know when it will end. I hope so. Otherwise, you have a project. And the budget goes from the beginning to the end for a project. For a product, you have a recurring yearly budget. In general, that's the biggest problem. People say, hey, we are doing microservices, but we are doing projects, right? So it doesn't fit the characteristics, so hence you are not doing microservices. You who said, hey, we are perhaps doing microservices, but we don't want to be this kind of developer. Are you doing products or projects? Products. So it's already good. So you might be doing microservices. At the beginning, when people were talking about microservices, they were very keen on mentioning the Conway's law. Really. Conway's law says that the communication channels of your company will actually influence your architecture. Your architecture will be mimicking the communication channels of your company. Nobody talks about this anymore. Now they are just saying, oh yeah, we will just use this pattern and everything will be fine. But if we focus on the organization, actually most companies have this kind of communication channel. You have UI specialists, you have middleware specialists, you have DBAs, and because of that you have a three-tier architecture. Makes sense, right? That's exactly what we observe. So if you want to have microservices, you need to have this kind of organization of communication around your company. In general, this is also not the case. Most people are still doing this kind of stuff. So who is doing the organization on the right? In general, the poster child is AWS. AWS has two pizzas team. So they are independent cross-functional teams. They don't need anybody to work. That's the point of microservices. And it should be small enough that it can be fed by two pizzas. So depending whether you are a big guy like me or it depends exactly. So it's not clear how many people, but it should be small team. But in order to move from the organization on the left to the organization on the right, we need the help of this guy. Or let's say this kind of guy. Who is this kind of guy? Who do I want to represent with this guy?
Banana.
No, I don't want to represent a banana because he has a banana in his hand. I want to represent somebody. What? Monkey company. Yeah, every company is a monkey company. So, who is dressed like this?
Blue collar person.
Sorry?
Blue collar person.
Manager.
Manager.
Manager, yeah. I mean, your manager or probably your manager's manager is dressed like this. Yes. Yeah. Hey, you can see, you enter an office, you have like developers, and you have managers, right? And it's even worse because in general, managers are not that bad. The problem is middle managers. I have had a couple of middle managers that were good. So I have worked for more than 20 years now. A couple of them were good. Most of them, however, were paid to accept my vacation requests, to be the proxy for my raise every year. And I said the proxy because you don't negotiate, like you've got X percent. Yeah, but no, you've got X percent, it has been decided. It's done. And to do a couple of dashboards that could be automated anyway. Most of the middle managers are paid for that. Couple of them, they add value to the company. Most of them, I don't think so. Who here is a manager? I will run faster than you anyway. So the problem is here is a middle manager at the top. Here is a middle manager at the top. Here is a middle manager at the top. Where are the middle managers here? Nowhere. It will be obvious that they don't fit anywhere. Because remember, the characteristic of such a team is that they are independent. They don't need somebody to actually accept your vacation request. You can receive your raise by email. Not necessary anymore. So the people who can help you change from the organizational left to the organizational right are middle managers, and basically they will be actually like sewing off their own jobs. So there is a huge, huge risk that you cannot change your organization when it's like this. You can start like this, but it's very hard to change from here to here, especially if the organization is more than, let's say, 40 people. It's already hard. Okay, so how does microservices work in real life? You have somebody, a technical person, who has no influence on the organization at all, and they say, hey, I've read in this article that microservices can solve all of our problems. Let's do that. And so you want to do it because, well, it looks nice. Everybody is talking about microservices. We are developers. We want to try new stuff. You do microservices. It doesn't work because of Conway's law, because the organization is not made for that. So you've got all the problems of microservices and none of the benefits. The guy who said, hey, let's do microservices, he understands it perfectly. But now he has microservices architect on his resume. So it will just leave, and who will be maintaining this mess? It will be you.
Me?
Yeah, you. No. Because you are working for the organization, and even if at the beginning you said, no, I don't want to do that, now you're responsible because you are paid to do that.
He could also prepare his CV.
He could also do that, and that would be the very, very smart thing to do. So you know what to do now. But why are people still doing microservices if they don't work for most companies? There must be a reason. What is so attractive about microservices that people are doing it even though it doesn't work in their organization? Followers cite three main benefits. Strong module boundaries, technology diversity, and independent deployment. So let's go through each of them to see if it's worth it. Strong module boundaries. Of course, if you have separate Git repositories, you cannot depend on another one, unless you have a monorepo and microservices, but if anybody can explain it to me, because I never understood the idea. There are like organizations doing microservices, but having a monorepo. I don't understand it. But if you have different Git repositories, yes, it works. But I don't think it's a good enough reason. Because it's like saying, hey, I want to write with my left hand, because I'm right-handed, I will cut my right hand. Then I will have no other choice than to write with my left hand, hence I will learn to write with my left hand. Yes, that's true. Sure. So it's not good enough. There are other solutions. There are other ways to achieve the same with less downsides. For example, if you are working in Java, you can have arc units or G molecules. Unit test, you write your architectural rules, you run them during testing phase. It fails, it's because you did something wrong. You didn't know about it? You look at me with wild eyes, like, what the hell is he talking about? You know about arc units?
No.
And that's a good thing. What are you going to do this evening?
I read about units.
Probably you will eat and sleep, and tomorrow morning you will read about arc units. It's still a good effort. Arc units, G molecules, you are in the Java world, you use them, same stuff. You can use Sonar, and you can check the package tangling rules. So you can fail your build if it doesn't respect the rules. So same way, much, much easier, less downside. Okay, so it's not the reason to do microservices. If you do microservices for this, it's a really bad idea. Technology diversity, everybody is talking about diversity. We must be diverse. We must have, like, shit, it's recorded. Okay, we must be diverse, especially in the US, where we are not diverse enough. It's good for people, perhaps, but if you think about it from an organization point of view, if you are a Java shop, you know how hard it is to recruit Java developers. Now imagine that now you don't only need to recruit Java developers, you need to recruit Rust developers and JavaScript developers and Go developers and whatever. What will you ask them in the interview? Worse, I assume everybody here is a Java developer? No, you are not. What are you doing at the CoffeeJUG user group? What's your stack?
I am an automation engineer.
Automation engineer, okay. So you don't write code at all?
Yes.
Okay. You are very courageous, very brave to come here. That's very good. Yeah, you got me. Yeah, good. That was one. Who here is not a Java developer and still a developer? You are not developer. What is your stack? .NET. Great. Very courageous as well. So I come to your shop. I am a Java developer. And I heard about .NET. I want to try it. But then at some point, I decided it's not good enough. And I want to create my Java microservice just for me. And people that I can recruit were .NET developers and are very interested in Java. And then I decided, like the architect, that the company doesn't pay me well enough. And I leave. Who is going to maintain that crap that I created? Manager, I'm not sure. Yeah, here, always the same guy. You should ask for a raise. Same crap. So it's not only about recruiting, it's also about maintaining. You will be in deep trouble. So from an organization point of view, the technology diversity is not a good idea. Really not. Independent deployment. That might be the reason.
Can I ask a
Yeah, you can ask questions. Not only one, but I have, like now, I have 15 minutes.
Okay, it will be quick. Regarding this
That's what she...
technology, it could be like the same language but different technology stack. For example, some microservices might need to use Spring because it's like more suitable. Some microservices could not have any REST API and not use Spring. So this could also be the technology diversity.
Yes. So you have less downsides, but still, how do you recruit? You are not a Spring developer. How do you recruit a Spring developer? You are a Java EE developer? Sorry, a Jakarta EE developer? And you want to recruit a Spring developer because you understand that Jakarta is just dead. Don't record that. How do you do it? So same crap. Maintenance as well. I can be very smart with Spring configuration, and if you are just a Spring newbie, it will be, like for example, I will say, oh, don't want annotation because, or on the opposite, I want annotations everywhere because blah, blah. Nah. So it's better from an organizational standpoint to have the same technology, the same language stack, the same framework, the same rules everywhere. It's not always feasible, it's not always enforced, but it still makes sense to have the same. And when they diverge, it's not because, hey, we wanted this here and this here, it's because somebody thought, hey, this rule there is super stupid, I will make my own here. And then when you switch project, what the hell? It's all about egos. So independent deployment might be the reason. So I assume you are familiar with this stuff. You have specification time, right? This is unfortunately not under our control because the business, they change their mind all the time. And now you've got implementation and deployment. This is under our control. And implementation and deployment is lead time. And you want the lead time to be as small as possible. So if you have independent deployment, the idea is you reduce the lead time. Okay, but you know what? This basically is time to market. And you know what? The idea of shortening time to market is not new. We already had the same idea long time ago. How did we did it? How did we do it? So in the old days, we had release trains. So at the beginning of the year, we planned the release dates. In general, there were 4 dates, so release 4 times a year. And the idea is, at this date, you should have everything ready, right? And of course, what happened? Sometimes it was not ready because the business changed their mind, or because you did a crappy job, or because somebody estimated the work that you should do and they had no clue. So we were late. And when we were late, that meant that the business had to wait 3 more months to get their feature in production. Do you think the business was happy about it? The business was super pissed off. And you wanted still to make the business happy despite the crappy rule. But there was a workaround, because if it was a bug, or even better, a critical bug, you could still ship to production outside of the release trains. So what did we do? We shipped unfinished features. And then we had to fix them. And we could ship anyway. So when you have stupid rules, you have stupid workarounds. And it worked. So there is also an assumption in microservices that says, hey, look, it's very hard to test the whole monolith during each release. But it's very easy to test only the microservice for each release. Henceforth, we can release more often. The hidden assumption that actually nobody points the finger to is that if you have microservices and you change something here, it doesn't have any ripple effect here. So basically they said the monolith has this problem, but microservices no. They are immune to this problem. Guess what? It's wrong. They are just less exposed, but it doesn't mean that if you change a microservice, you won't have any change in consumer microservice. What do you think? Meh. You are not listening to me. So the real problem is the following, I believe. I've worked 17 years in consulting, so on real apps before I became a developer advocate. And my experience, which is personal, seems to be shared by others, is that when you work on an app, on a service, on an application for several years, you notice that some parts, they change very often, and some parts, they are super stable. So basically, the idea becomes, why don't you just care about the parts that are changing fast? And there are not that many. In general, it's two problems. Parts that change fast is because of the business, and parts that change randomly, it's because of laws. So business is internal factor, and laws is external factor. But in any case, you want to be able to deploy those ones fast and frequently. Remember about rules engine? Who knows about rules engine? You don't know? No, really? Drools? Drools in Java? Never heard about drools? You're not a Java. What kind of developer are you? PHP. No. That's very, very outside my knowledge sphere. Yeah. So the idea is that you have an engine that you deploy once in production, and then you have a rule or rules that can be, wait for it, changed directly by the business without any intervention by IT, directly in production. If you see lots of red warnings when I say that, that's normal. That's pretty crazy, but that's what we did. The idea is that because of this heavy process that we had before, some businesses wanted to bypass the process. So they wanted to say, we don't want to deal with IT. We want to be completely independent. So there were rules engine for that. I never used any, but once I had a colleague having as a requirement to use a rule engine. So I asked, hey, can you show me how it works? Like, I checked the rule. There was one single file. Honestly, no business person could have changed the rule by themselves. You needed to be a developer. It was really complex. And then you are not just any kind of developer. You needed to know about the business. So this idea that, hey, anybody can change it, blah, 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 is just bullcrap, in my opinion. But still, it was a way to actually be flexible, to deploy often. And don't ask me about, hey, when do we change it? How do we roll back? That data is corrupted. You are very, very right. There were lots of problems with that. Anyway, that was one way. So my idea is, regardless of the exact implementation, be it a rule engine, a microservice, a serverless function, or whatever, the idea is you isolate the quick changing part. And I don't know if you have read the book Microservices in Action by, I don't remember the guy's name, Chris Richardson. Do you know about the book, Microservice? It's a huge book, very interesting if you are a Java developer. It goes through all the steps that you need to implement in order to do microservices from a technical point of view, not organizational, technical. I bought the book. Halfway throughout the book, I say, nobody is crazy enough to spend that amount of time to do that stuff. And I put it back on my shelf. It's a great book anyway, but it's really, really hard. I have 5 minutes, I understand the idea. So there is a companion website, and his idea is to have a couple of design patterns to implement microservices. And one of them is strangling the monolith. So basically you start with a monolith, then you chop one port, 2 ports, then 3 ports, then more ports, and at the end, there is no monolith anymore. And my only question is why wouldn't you stop there and keep all the stable ports, the not quick changing port, in the monolith? Why would you need to go there? If you're to-be architecture, if you are a microservices guru, yes, this is your to-be architecture, this is your target, this is your goal, this is your El Dorado. But if you are pragmatic, you can just stop there and be happy. So now I will do a demo. I will do a demo on e-commerce. So I will skip the slides, blah, blah, blah. And I have this, I have two flavors. The one is actually a complete monolith. So they call it like server. Now it's, what's the name? Like server rendered pages or something like this, like regular Spring stuff. You generate the pages on the server, you send the HTML. The other is as a server with API and a client in JavaScript. Which flavor do you want to see? The second one? Yeah. Everybody agrees? Yeah. Good. So here I start the stuff, and meanwhile I have a Docker Compose file. I will still use API 6. I will also use etcd for the same reason as before, as dynamic. Here I have my backend, and here I have my front end. And here I have MariaDB. So the idea, it's an e-commerce app. I hope it has started now, yes. And of course, I need to configure API 6. So now you can understand. Here I have created one route, right? It catches everything, and it sends everything to the front end. Now I have created another route, and now if I say it starts with API, you remove the API prefix, and you send the upstream to the backend. Like nothing mind-blowing. Okay? Now I will go here, go to localhost 9080. And you see I'm still able to do some demos. I'm still a developer. So this is Bootstrap v5. Yeah, it sucks, but hey, I'm not a front-end engineer. I can add stuff to my cart. Here I have something important, perhaps. So you can see it's really like API calls. So I have one call to get the version, one call to get the catalog, and one call to get, I don't remember what it is, the quantity. Okay? Yeah, to get the number of items in the cart. So I get the response, and through JavaScript, I update. You see, I can do JavaScript as well.
No need for Vaadin.
No need for Vaadin. And here, I have two calls. So the first one does, sorry, I need to force. It's not good, sorry. I didn't bring it down yesterday. I did the demo, but I didn't bring it down, and still I have remnants of stuff I don't want to have at the moment. So of course, now I didn't implement session persistence. Okay, so now I have two calls. The one is one I still get the version, and the second I get the checkout. So basically, the checkout returns me the lines of the cart and the pricing. How did I implement it? That's quite easy. I get to my chop backend, and the pricing is here. So I'm sorry, it's Kotlin, but it's very similar to Java. Probably if you are a .NET developer, it's still clear. About PHP, I'm not sure, then you will decide. But basically, it's here. I call the pricing function. So where is it called? Here, I create the checkout view. So The checkout view is basically the JSON object that I will return to my front end, and it will be JSONified automatically. I pass the card, and I pass the pricing of this card. So the idea is this pricing will probably change at the moment, and for the whole demo, it will be just the sum, because I don't want to do anything complicated, but the idea is I want this to be changeable. At the moment, it's not changeable. The first thing I need to do is to actually make the pricing an HTTP route. So I make pricing a HTTP route. What does it mean? It means first I need to bring this stuff down. And then the code changes in this way. So now I have a checkout view, and we don't care about the pricing. And we have a pricing view, and then the pricing view is here, and we call a dedicated route. Now, normally the client would do checkout, get the items from the cart, and then all the items from the cart, they should be sent to pricing, right? This is actually the worst thing you can do, because it means that now you probably doubled your latency, because now instead of making one call, you are doing 2 calls. But what we can do is we can be smart and handle it on the API gateway side. So if we handle it on the API gateway side, it gives the following configuration. Now you can read it like before. Everything goes to the front end, then the API go to the back end, and then API checkout. So when I'm calling checkout, I will remove the API as before, and then I will do this dance, getting the cards and then asking for the pricing. I do it on the API gateway. So here I'm actually queuing the 2 requests. The response from the checkout will be fed to the price. And then I need something is actually to set the content type, otherwise it's not happy. So if I run this, so I didn't change the front end, I just changed the back end. Still the same stuff. You see that the version of the back end has changed. So I can add here and here and here. And there, I still have 2 calls. And now I'm able to chop the port I don't like. How do I do it? I will just intercept the port that I don't like, and here I will say, instead of the pricing going to the monolith, I will just send it to the chopped port, which is in this case anything you want, but because everything is configured for Azure, I will use Azure. I don't deploy anything else. I just change the configuration of the API gateway. So here, this is the stuff that will change. Sorry, here. On the checkout port, here, I will add a new route, the route number 4. And when I send API price, instead of saying it to the backend, I'm using an Azure function that I prepared beforehand. So if I run it, again, I didn't deploy any new container. I didn't do anything. If I refresh, and here you see it's a bit slower because I'm going to the clouds. And here we can see in the JSON that I added before that the source is Azure. And now you can change your serverless function anytime you want. You keep the monolith. So you've got the best of both worlds because you just moved the port that was fast changing outside of the monolith. You keep the stability. And you can wait 3 months. At the next release, you remove the date code that you don't use anymore inside the monolith. And I didn't do it in the time frame that was assigned to me. This is the sequence diagram, and it's still the same stuff, so this is more important. This is what I'm doing. I'm calling checkout, the API6 gateway, get the cards from the monolith, and send the pricing function with the cart lines to the upstream, in that case, a serverless function. Computation, you return the price and the cart, and it's done. If so. So thanks a lot again. Do we have 5 minutes for question, or we need to go away unless?
Yeah, we have 5 minutes.
5 minutes? Well, if you have no question, it's different, but if you have questions, I will be taking questions. Or not? Okay, no questions, so even better. So thanks a lot for your attention.